A new study shows that instead of forming alone, our Milky Way galaxy was involved in a major collision with another big galaxy about 10 billion years ago. This other galaxy, which has now been named Gaia Enceladus, was about a quarter the size of the Milky Way at the time. And evidence of this galactic collision is now littered across the sky in plain sight. You just have to know what to look for. The stars of Gaia Enceladus make up most of the Milky Way's halo and also help shape the galaxy's thick disk, giving it its inflated appearance. The findings, reported in the journal Nature, are based on the first 22 months of observations by the European Space Agency's Gaia spacecraft. Gaia measures the position, movement and luminosity of stars to unprecedented levels of accuracy. The authors reached their conclusion after looking at the full three-dimensional positions and velocities of some 7 million stars. They found that some 30,000 of these stars appear to be part of an odd collection moving through the Milky Way. The study's lead author, Professor Amina Helmi from the University of Groningen in the Netherlands, says the stars from this other galaxy are currently passing through our solar neighbourhood. In fact, the stars in our neighbourhood are deeply embedded in this collection of alien stars, which are almost completely surrounding us. Even though they're interspersed with other stars, the stars of this alien collection stood out in the Gaia data because they're all moving along elongated trajectories in the opposite direction to the majority of the galaxy's 100 billion stars, including that of the Sun. These stars also stood out in the Hertzsprung-Russell or HR diagram. That's an astronomical tool used to compare the colour, mass and luminosity of stars at different ages of their evolution. The HR diagram shows that these stars all clearly belong to a distinct and separate stellar population. The sheer number of odd-moving stars involved intrigued Helmi and colleagues, who suspected they might have something to do with the Milky Way's formation history, and so set about trying to understand their origins. In the past, these authors have used computer simulations to study what happens to stars when two large galaxies merge. And when Helmi compared those to the Gaia data, the simulated results matched her observations. Helmi says the collection of stars she found with Gaia have all the properties of what one would expect from the debris of a galactic merger, which stars from another galaxy were cannibalized by the Milky Way. These stars now form most of our galaxy's inner halo, a diffuse component of old stars that were born at earlier times, and now surround the main bulk of the Milky Way known as the central bulge and disk. The galaxy disk itself is composed of two parts. There's the thin disk, which is just a few hundred light years deep and contains the pattern of spiral arms made by bright stars. Then there is a thick disk, which is a few thousand light years deep. It contains about 10 to 20% of all the galaxy stars, yet its origins have been difficult to determine. According to the team's simulations, as well as supplying the halo stars, the accreted galaxy could also have disturbed the Milky Way's pre-existing stars, in the process helping to form the thick disk. The authors became even more certain about their interpretation after complementing the Gaia data with additional information about the chemical composition of the stars supplied by the ground-based Apogee survey. You see, stars that form in different galaxies have unique chemical compositions which match the conditions of the galaxy in which they formed. So if this star collection was indeed the remains of a galaxy that merged with the Milky Way, the alien stars would show an imprint of this in their chemical composition. And when their spectra was examined, they did. The authors have named the other galaxy Gaia Enceladus after one of the giants of ancient Greek mythology, who was the offspring of Gaia, the Earth, and Uranus, the sky. According to the legend, Enceladus was buried under Mount Etna in Sicily and is responsible for all the local earthquakes there. In a similar fashion, the stars of the Gaia Enceladus galaxy were deeply buried in the Gaia data. And their collision with the Milky Way have shaken our galaxy, leading to the formation of its thick disk. The authors also found hundreds of variable stars and 13 globular clusters in the Milky Way, which follow similar trajectories to the stars from Gaia Enceladus, indicating that they too were originally part of that system. Globular clusters are tight gravitationally bound spheres containing thousands to millions of stars, which were all originally formed in the same molecular gas and dust cloud at the same time. The fact that so many globular clusters could be linked to Gaia Enceladus is yet another indication that this must have once been a very big galaxy in its own right, with its own entourage of globular clusters. Based on stellar population, the authors suspect that Gaia Enceladus probably had about a tenth the mass of the Milky Way, making it just as big as the Large Magellanic Cloud is today, one of the dwarf satellite galaxies currently orbiting the Milky Way. However, 10 billion years ago, when the merger with Gaia Enceladus took place, the Milky Way itself was much smaller, and so the ratio between the two was more like 4:1. It was therefore clearly a major blow to our galaxy.